Hello there, welcome to this YouTube channel. This is New Life Academy. You are in the right place. Today we're going to be studying chemical kinetics. Let's get right into it. Chemical kinetics is the study of the rate and the factors that affect the rate of a chemical reaction. The rate of a chemical reaction and the factors that affect the rate of a chemical reaction. So the first thing we're going to be looking at is the rate of a reaction. What's the rate of a chemical reaction? The rate of a chemical reaction is the decrease of the concentration of the reactants with respect to time, or the increase in the concentration of the product with respect to time.
As easy as that.
Yeah, the decrease in the concentration of the reactants with respect to time, or the increase in the concentration of the product with respect to time. We have different rates that we could define: instantaneous rate, initial rate, and the average rate of a chemical reaction. So how do you define the initial rate of a chemical reaction? The initial rate of a chemical reaction is the rate at the beginning of the reaction, like at the beginning of the reaction process, when so many reactants have not been converted into product. At the beginning of the chemical reaction, that is the initial rate of a chemical reaction. How do you define the average rate of a chemical reaction? The average rate is the total change in concentration of the reactant with respect to time. The total change, that is all through the reaction. The total change in the concentration of the reactant with respect to time. So the formula to calculate the rate of a chemical reaction, you get the concentration of a particular reactant at time T2 minus the concentration of that same reactant at time T1, all that divided by the time T2 minus T1. Yeah, because rate is with respect to time, so we must always divide by change in time. Now we're going to be looking at the factors that affect the rate of a chemical reaction. You have five factors. Five factors affect the rate of a chemical reaction. We have temperature, surface area, catalyst, light, and concentration of the reactant. All of these factors affect the rate of a chemical reaction. The first one we're going to be looking at is temperature. How does temperature affect the rate of a chemical reaction? An increase in temperature will cause an increase in the rate of a chemical reaction. How does temperature increase the rate of a chemical reaction? This is what happens. When you increase the temperature in the course of a reaction, the molecules of the reactant, they gain kinetic energy. And as they gain kinetic energy, they begin to move at a faster velocity, causing what? Effective collisions to occur more within the reactants, leading to what? Formation of products, thereby increasing the rate of the chemical reaction. So when you increase the temperature of a reaction process, you increase the rate of that reaction. The second thing we're going to be looking at is the concentration of the reactants. The concentration of the reactant, increase in the concentration of the reactant will lead to an increase in the rate of a chemical reaction, and this has to do with liquid and gaseous reactants. So if you increase the concentration of the reactant, what you do is that you reduce the spacing between the reacting molecules, and reducing the spacing between reacting molecules will cause effective collisions to easily occur. You see, because the molecules become closer to each other because they are concentrated in that area. So the molecules will be close to each other, and therefore effective collisions will increase, increasing what? The rate of the chemical reaction. So that is how concentration of reactants increase the rate of a chemical reaction. The next thing we're going to be looking at is the surface area of the reactants, and this has to do basically with solids. Yeah, because if you have a reaction that's really solid, and the solid reactants are still they are found in the form of lumps, like lumps. It'll be difficult for the molecules of that reactant to collide together. It will be difficult for all of them to collide together to form products. A very simple example: imagine you're supposed to blend beans and maize, corn and beans. Imagine you have to blend the two. The mixing will be difficult, but imagine that you actually ground the maize and the beans. Mixing will become easier. So how do you increase surface area? By changing it from that solid form, that lump nature, to that lump form, to making it powder. That's how you increase the surface area for the reaction. So increasing the surface area will increase the rate of the reaction, and will make products to be formed easily. Increasing surface area of reactants would increase the rate of the chemical reaction. The next thing we're going to be looking at is catalyst. How does the catalyst increase the rate of a chemical reaction? It does it in two ways. The first thing is that it decreases the activation energy of the reaction. What's the activation energy? The activation energy is the minimum amount of energy needed for a reaction to take place. So a catalyst will do what? It will reduce the activation energy. For example, if the activation energy was maybe 1000 joules, in the presence of a particular catalyst, the activation energy will become about 300 or 500 joules. Another thing that the catalyst does is that what? It provides an alternative pathway for the reaction to occur. It provides an alternative pathway for the reaction to occur, thereby making the reaction to occur at a faster rate than in the absence of that catalyst. So catalyst will increase the rate of the chemical reaction. But one thing to take note of concerning catalysts is that they are permanently unchanged in the course of or at the end of the reaction. They don't take part chemically in the reaction process. And the last thing we're going to be looking at is light. Light affects the rate of chemical reaction, and this really has to do with light dependent reactions, because they provide a photochemical effect. The photochemical effect provides is similar to the effect of the catalyst. It provides an alternative pathway for the reaction to take place, thereby increasing the rate of the chemical reaction. So the 5 things that affect the rate of chemical reaction: the first is temperature, the second is the concentration of the reactant, the next is the surface area of the reactant, the next is the catalyst, and the last is light. Keep all of these 5 points in mind and understand how they affect the rate of chemical reaction. Now the next thing we're going to be looking at is the rate equation. The rate equation. What is the rate equation? It's also called the rate law. This is a mathematical relationship between the rate of a reaction and the concentration of the reactant raised to various powers. We're going to see a picture of what a rate equation looks like. So this is an example of the rate law. This equation has a constant K. What is the constant K? The constant K is the proportionality constant in the rate equation. And K depends on several things. The first thing that K depends on is the nature of the reaction. K will be higher if the rate of the reaction is very high. If the reaction went on speedily, you realize that when you calculate K, K will be very high. But if the reaction was slow, K will be very low. So K depends on the rate of the reaction, how the reaction took place, either fast or slow. K also increases with temperature. If the temperature was high, K will be high. If the temperature was low, K will be low. So K depends on what? The speed of the reaction, or the rate of the reaction, and the temperature. Now the next thing that we see on the rate equation, that the powers. You see the concentrations are raised to a particular power. The different concentrations are raised to a particular power. And these powers is what we call the order of the reaction. The order of the reaction. So what is the order of a reaction? The order of a chemical reaction is the power to which the concentration of the reactants are raised to in a chemically determined rate equation. So if you have a chemically determined rate equation, as we saw earlier, the rate equation, the rate law we saw earlier. In the rate law, the power to which the concentration of the reactants are raised to is what we call the order of a reaction. We also have what we call the overall order of the reaction. The overall order of a chemical reaction is the sum of the different orders of a reaction. Because we have the order of a reaction with respect to a particular reactant, reactant A, reactant B, reactant C. Now the overall order of the reaction is the order with respect to A plus the order with respect to B plus the order with respect to C. Now, how do you determine the order of a chemical reaction? We have 3 principal methods by which you determine the order of a reaction. The first method is through the concentration time graphs. You can also call it the half-life method. Using the half-lives. So how does this principle work, or how does this method works? when you plot the graph of concentration against time, it's similar to the graph of the half-life. So if the half-life remains constant with respect to time, or yes, if the half-life remains constant as time goes on, it's a first order reaction. If it increases with time, it's a second order reaction. And if it decreases with time, it is a zero order reaction. This is the first means by which you determine the order of a chemical reaction. You can also determine the order of a chemical reaction by using the rate concentration graphs. On the rate concentration graph, as it's plotted, a first order reaction is a straight line from the origin. First order reaction. And a second order reaction is a curve. So you have rate against concentration, and they have a curve in this direction. That is the second order reaction. The third method by which you can determine the order of a reaction is using by the initial rate method. To know the order of a reaction using the initial rate method, you go by doubling the concentration of the reactant. If you double the concentration of the reactant and the rate remains unchanged, we are dealing with a zero order reaction. If you double the concentration of the reactant and the rate doubles, we are dealing with a first order reaction. If you double the initial concentration of the reactant and the rate quadruples, we are dealing with a second order reaction. If you double the rate of the initial reactant and the rate increases by a factor of 8, we are dealing with a third order reaction. So this global understanding of chemical kinetics will enable you to answer questions in the GCE and other national and international exams that have to do with the rate of chemical reactions, and will help you to also handle calculations that has to do with chemical kinetics. Now, I would invite you to give us a thumbs up if you haven't done that before, because I believe that this video has been helpful to you. And don't forget to subscribe to our YouTube channel, and click that notification bell so that you will always be